Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to Rational Expressions. Again, with expressions, we're not working with anything that has an equal sign, and the word rational means it can be written as a fraction. So we're talking about stuff like 2x divided by the quantity x minus 1, y minus 2 over y squared plus 4, x cubed minus x divided by x squared minus 5x plus 6. And there's a lot of different ways that we can write them, but one of the first things that we're going to focus on is things about the domain. So domain is what can I substitute for x or y, depending on your variable. So your domain is going to be, you're going to assume it's all reals. Dot, 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 because, right? So you're going to start by saying, hey, it's all reals, unless, except we know that the denominator cannot equal 0. The reason for this is you can't take something and divide it into nothing. So keep that in mind. So I did have one coworker that say a number divided by 0 is no. 0 divided by a number is game on. Okay, so if you're ever wondering about that, which way is it, n over o, no. So the denominator cannot equal 0. Also, just a quick refresher, anytime you have an even index and you have a number underneath here, let's say let's call this a. A must be greater than or equal to 0. So denominator cannot equal 0, and even radicals have to have a radicand greater than 0. So then I just want to look at several of them, and I want to look at the domain. One over x. Okay, so assume everything works except the denominator cannot be 0. So see if I can't get that to refocus again. We know, in this case, x cannot be 0. Okay. Square root of x. Well, 1, this is not rational because it's not a fraction, but we can still do the domain x is greater than or equal to 0. So what about 1 divided by the square root of x? Oh, now, because x is in the denominator, x can't be 0, but because of the square root in the square root, x has to be greater than 0. So the denominator kicks out 0, the square root kicks out all the negatives, so now the domain of this one is strictly greater than 0, because it's basically putting these two together. So making sure that we can write those domains in proper format. This would be x is an element of negative infinity to 0, or there's that union sign, 0 to infinity. So we skipped over 0. Here, this is x as part of the group starting at 0 and continuing to infinity. And this is part of the group starting close to 0 and continuing to infinity. So see the difference in those three. If you have a polynomial, such as x squared minus 8x plus 5, there is no denominator, there is no radical, so the domain is anything. So I'll just go ahead and put this right into interval notation. Okay. Switch colors here just so that we can see the difference in the problems. Okay. What about the expression x over x squared minus 5x plus 6? Oh, okay, so I'm going to rewrite that in factored form. If you don't know how to factor, either go back and watch my Algebra 2 factoring videos or the video right before this where I go over some college level factoring. So this will be the factoring x minus 2, x minus 3. So 2 and 3 both could result in this denominator being 0. So we have to kick out 2 and we have to kick out 3. So that turns our number line into 3 different elements or parts. So we would say x is between negative infinity and 2, or it's between 2 and 3, or it's between 3 and infinity. And this, if you're taking a college course, this is the preferred way of writing it generally. So make sure that you understand what the symbols mean here. So let's try one more. The square root of x over x minus 5. Okay. So because of the denominator, x cannot be 5, so we have to kick out 5. Because of the numerator, we can only do square roots of 0 and higher. So because of the numerator, we have to do 0 and higher. So when I put those together, x is between 0 and 5. 0 is included, 5 is not. Or between 5 and infinity, and those neither one are included. So being able to write your inequality notation like that is really important to being able to say, hey, this is my domain. So a lot of times in a college algebra or pre-calculus class, this interval notation is going to be the expected mean. All right, so if we're going to have rational expressions, just like any kind of fraction, we're going to have to be able to reduce. So let's go ahead and let's simplify the quantity x squared minus 1 over x squared plus x minus 2. So the best way to simplify these is just to reduce them by a common factor, and in order to reduce by a common factor, we must first factor it. Now I will say before I reduce, I always get my domain, just in case I need it. So I factored both. Because the denominator, x cannot equal negative 2 or positive 1. So if I think about that number line, I have to kick out negative 2, I have to kick out positive 1. X is somewhere between negative infinity, negative 2, or negative 2, 1, or 1, infinity. Now that I have my domain, I do see a common factor of x minus 1, so I'll cancel it out. And my final answer is x plus 1 over x plus 2. Note, x is not negative 2 or positive 1. Okay? Not so bad if you can factor. The better your factoring skills, the better these rational expressions are. So maybe they don't just ask you to simplify, maybe they ask you to multiply. So multiply x squared plus 2x minus 3 over x squared plus 8x plus 16 being multiplied by 3x plus 12 over x minus 1. If you start multiplying these fractions immediately, you're going to get a cubic function on the top, a cubic function on the bottom, and then you're going to have to simplify it later, and that could become a nightmare. So my recommendation is to, number one, just go ahead and factor. So the first numerator is x plus 3 times x minus 1. The second numerator has a GCF of 3. The first denominator is x plus 4 or x plus 4. And the second denominator doesn't have anything, so it's just x minus 1. So we can see right here that x cannot be 1 or negative 4. So the domain is negative infinity to negative 4, or negative 4 to 1, or 1 to infinity. But the bigger thing is when we multiply fractions, we're really just multiplying the top and multiplying the bottom. So really it's kind of like this numerator-denominator line just kind of extends, and they're all in one numerator, all in one denominator. So do I have a common factor in the top and in the bottom? Yes, I do. I actually have 2. I could divide the top by x plus 4 and the bottom by x plus 4. I could also divide the top by x minus 1 and the bottom by x minus 1, leaving us with 3 x plus 3, just because I thought it looked prettier to write the 3 in front, over x plus 4. Or, if you really felt like it, you could go ahead and distribute. I would accept either in my classroom. And then we note x cannot be 1 or negative 4. So the equals with a slash through it means cannot equal. Okay, so multiplying fractions, not so bad if you can factor. What about dividing these rational expressions? And the reason why they say simplify instead of solve is because there's no equal sign. So it's just a vocab word that your textbook might say simplify. Again, the first step here is going to be factor, 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 factor. You're going to hear me say factor is your first step a lot. So x minus 4 is prime. There's no coefficients and there's no exponents. X squared minus 4 is x plus 2. X minus 2, that's that special pattern, divided by, multiply to negative 4, add to negative 3, x minus 4, x plus 1. Your goal as a student is to get your factoring that quick. Multiply to 6, but add to 5, that would be 2 and 3. This time I'm not going to write out the domain, I'm just going to say what the domain can't be. So the domain x cannot be 2, negative 2, negative 2, or negative 3. So there were 3 things that x plus 2 is repetitive. To divide fractions, we can't actually divide fractions. What we have to do is we have to multiply by the reciprocal. So we'll keep the first one. Multiply by the reciprocal. When we do that though, new items show up in our denominator. And so we have to gain additional issues. Now, a domain error happens at 4 and at negative 1. So don't forget to add those onto the list. Okay, so anytime anything appears in the denominator in any way, shape, or form, you have to cancel it out. Okay, now it's just back to multiplying. We can divide the top and bottom by a factor of x plus 2. We can divide the top and bottom by a factor of x minus 4, which would leave us with x plus 3 over x minus 2, x plus 1. And generally the directions do say to write it as a simplified expression. In my mind, this is simplified because I can clearly see that this is a reduced fraction, and I actually happen to love factored form instead of expanded form because I can do so much with them. So again, if you really want to write the domain, just to highlight the idea behind the domain, we have to kick out negative 3, negative 2, we also have to kick out 2, and we have to kick out 4. So this really is a very long domain to write, but if you truly had to write it, we would go from negative infinity to negative 3, or negative 3 to negative 2, or negative 2 to negative 1, or negative 1 to positive 2, or positive 2 to positive 4, or positive 4 to infinity. Sorry about the pen drags there. So this is one of those that is a bit redundant to ask somebody to write the domain down for, but sometimes noting where x cannot be is a lot simpler than writing down the true domain. So that's why we just had that list of x cannot equal 2, negative 2, negative 3, 4, negative 1. So I find multiplying and dividing rational expressions very easy. On the other hand, when it comes to adding, this is when it gets a little more tricky. With fractions, we have to have a common denominator. Now, I never want to multiply by more than I have to, so I'm going to go ahead and put parentheses around this. Now, x minus 1 is a prime factor, x plus 2 is a prime factor. Since they're both primes, we can just go ahead and multiply the two together to get that common denominator. So if you remember from adding basic fractions in junior high or elementary, we're going to go ahead and multiply the first fraction by something to give it the same denominator as the second. So I'm going to multiply x plus 2, and x minus 1, x minus 1. And this will give us a common denominator. So now I'm going to have the first numerator plus the second numerator over my common denominator. And of course, we know that x cannot be 1 or negative 2. Now, the denominator is okay to leave like this because it is in factored form. It is a single term. It's written as a product. This plus sign right here in the middle, though, tells me that that's not written in factored form. So you have two options. You either need to write it in factored form or you need to write it in expanded form. Not a mixture of the two. And right now it is a mixture of the two. So I'm going to go ahead and distribute 3x plus 6 plus x squared minus x. Of course, we have that common denominator. Combine like terms. I like to write it in descending form. Okay, and now the top is in expanded form and the top is in the bottom is in factored form. Can I leave the numerator expanded and the denominator factored? Absolutely. Also, if you noticed, the numerator does not factor. There is nothing that utilizes real numbers that multiplies to 6 and adds to 2. So this actually is in reduced form. And just note that our domain does not include the numbers 1 or negative 2. I find that student errors start happening in the next kind of problem. Because a lot of students want to treat this one exactly like we treated the one that was prime just a moment ago. And I would highly encourage you not to do that. One, they want to treat the denominators the same as in the last example, and then two, sign errors happen because this is a minus, not a plus. So be careful with signs. Again, factor, 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 factor. Okay? So we really have 1 over x plus 1, x minus 1, minus 2 over x plus 1, x plus 1. And if you're a student who's prone to sign errors, here's what I would do is I would not write minus on this step. I would write plus negative, and that negative only goes to the top, then that numerator. Okay, so we can see this has two x plus 1s, but this only has one x plus 1. So if I multiply this by x plus 1 top and bottom, it will match the other one as much as possible. But now this one needs an x minus 1. So had I multiplied the first by the second and the second by the first, I would have wound up with 4 different quantities in my denominator. And in this way, I only have 3. So that's much easier because now I'm not winding up with x squared in my numerator and having to factor down later. So now we're going to go ahead and multiply that out. We'll have x minus 1 plus negative 2x plus 2 over our common denominator of, I'm going to shorthand it here, x plus 1 twice, x minus 1. So I went ahead and actually did the distribution step right there. Now we can combine like terms, negative x plus 1 over x plus 1 squared, x minus 1. Do I have a sign here? I do. Thought I had a sign here. When this was a plus 1, I got ahead of myself in my brain. That needed to be a plus 1. So that's a plus 1. So that's a plus 3. I didn't remember this one reducing. Okay. So that is our final answer because it does not reduce. X cannot equal 1 or negative 1. Now, just a quick note. that if you ever have the following type of answer, 5 minus x over x plus 2 x minus 5. I know some of you would be inclined to say this doesn't reduce because the top one is 5 minus x and the bottom one is x minus 5. But think about this. That's negative x plus 5, which is negative 1 x minus 5 over that denominator of x plus 2. Now that I factored that GCF of a negative 1 out so that would be in the same order, keep that denominator the whole time. Now it does reduce. So be careful that you don't just assume that because this is 5 minus x and this is x minus 5, it doesn't reduce. It does because pick any two numbers, subtract them in the other order. See how you're getting the same number, just one positive, one negative? That's why it divides out like that. Okay? So common denominator, super important. Just try to go for the least common denominator. If you're having trouble figuring that out, I do have in my Algebra 2 video when I'm adding, subtracting, multiplying fractions, actually mostly adding and subtracting, a way of getting a common denominator using Venn diagrams. You're welcome to go back and watch that Algebra 2 video. The other thing that you might see at some point in time is compound fractions. Compound fractions mean we have fractions inside fractions. Your final answer can only have a single numerator and a single denominator. You can't have a numerator with a fraction inside of it or a denominator. So if you have 1/5 over 2, you cannot leave your answer like this. Okay? Normally we would think 1/5 divided by 2, which is 1/5 times 1/2. 1/5 times 1/2, which is 1/10. Okay? The other way you can think of it is I'm going to times the top and the bottom by 5. 1/5 times 5 is 1. 2 times 5 is 10. So we were able to clear fractions out with one step, not two. So our compound fraction that we're going to start getting into is, let's try 1/2 plus 1/3 over 1/5 plus 1/6. Okay, option 1. 1/2 plus 1/3 divided by 1/5 plus 1/6. Okay, well these have a common denominator of 6, so I'd have 3/6 plus 2/6, that's 5/6. Divided by a common denominator 30, 6/30 plus 5/30, that's 11/30. And then keep switch flip. 5/6 times 30 over 11. 30 is really 5 times 6, so the 6's will cancel, and that leaves me with 25 over 11. Whew, that's multiple steps. Or, watch this fun little trick. If I were to look at 2, 3, 5, and 6, they all go into 30. So I'm going to multiply the numerator by 30 and multiply the denominator times 30. 30 times 1/2 is 15. 30 times 1/3, 30 times 1 divided by 3, right, is 10. 30 times 1/5 is 6. And 30 times 1/6 is 5. Which gives us 25 over 11. Much fewer steps. So basically I just multiplied 30, or 30, technically 30 over 1, right? So I just kind of put times 30, times 30, times 30, times 30, and that popped in there. And if you're a person who has to do one of these for like Quiz Bowl or something, that's a fast way to do it. But we're going to be doing them for algebra, right? Okay. So this problem is going to read x over y plus 1 over 1 minus y over x. Now right here we notice that y cannot be 0 and that x cannot be 0. And we also know that 1 minus y over x cannot be 0. So that means 1 cannot equal y over x. So that means y cannot equal x, right? This here in the middle was just work to try to get to that last statement. I just set the entire bottom denominator equal to 0. So instead of getting a common denominator on the top, getting a common denominator on the bottom, and then switching it, I'm going to say, look, if I were to multiply this by y, it would get rid of this denominator, multiplying by x. So I'm going to multiply by everything by xy. I'm just distributing it. That's all I'm doing, instead of writing 2 steps where I distribute it. So here in the first one, the y's will cancel out, and I'll be left with x squared plus xy minus y squared. Okay, or I could try factoring it to see if it reduces. X plus y, x minus y. Okay, so right here, we're also seeing that x cannot equal y, because if they were the same, it would equal 0. Nothing factors, nothing reduces, so we're done. X can't be 0, y can't be 0, and x cannot equal y. The last thing is a rational fraction that has a binomial denominator that is irrational. We cannot have that in the denominator. 1 plus the square root of 2 is a long decimal. We talked in a previous lesson that I had posted that you cannot have long run-on decimals in the denominator. So we need to be able to fix this, okay? Now, in the previous video, you would have just multiplied by square root of 2. Okay, well that gives me the square root of 2 over 1 square root of 2 plus the square root of 2 squared, or the square root of 2 over square root of 2 plus 2. It's still irrational. So this previous idea that worked for us when it was a monomial no longer works for us when it's a binomial. Again, a binomial right there. So because it's a binomial, we're going to need to multiply by a binomial. And so we're actually going to use the conjugate. And you might have heard me talk about the conjugate when we talked about the a plus b, a minus b pattern, because it always equals a squared minus b squared. Okay, well we have the plus part, so we need the minus part. So since this is 1 plus square root of 2, we're going to multiply by 1 minus the square root of 2. Whatever we do at the bottom, we do at the top. So 1 times 1 is 1. In the denominator, we'll have 1 minus root 2 plus root 2 minus root 2 squared. And you'll notice these cancel out, and the square cancels the square root, so I just have 1 minus 2, which is negative 1. I do not like leaving a negative in the denominator, so this divides pretty easily. So it'll give me negative 1 plus the square root of 2. Now, the fun thing here on our calculators is that when you have a number multiplied by its conjugate, the calculator can handle it. Let's say you had 5 minus the square root of 3, right? Got to use those parentheses. Well, its conjugate is going to be 5 plus the square root of 3. And that equals a nice integer. So remember, anytime you have an irrational binomial in the denominator, you're going to need the binomial conjugate to finish that out.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.